Question number 4. Find the potential difference between A and B and current through each branch. Okay. R2 is short circuited and point A is connected to point B, then find the current through E1, E2, E3, and R. So in this case, these are three different batteries, E1, E2, E3, R1, R2, R3. We can consider their internal resistances. Now, based on that, we can make it as one combination, finding the equivalent resistance and equivalent EMF of this combination. Right? This is TPP number 6, Kirchhoff's law and circuit solving. Question number 4 is that there are three resistors, there are three batteries in parallel. So parallel combination of battery may, if you remember the formula, then formula for equivalent EMF of, क्या था बेटा formula बताना, कौन बताएगा? Mr. Yes, Shreya.
So n times r.
नहीं.
So
E1
1
by
by
R1.
r by 1 equivalent denominator में.
Denominator में 1 by R equivalent and that is 1 by R1. That was when it was identical. Here it is not identical.
Yes,
जब
sir.
different EMF के होंगे, then equivalent EMF is this. So E1 is 3 और resistance सारे 1 ही है. So 3 plus 1. All or the EMF are in same direction. 2 by 1, 1 by 1. Divide by 1 by 1 plus 1 by 1 plus 1 by 1. So that is 3 plus 2 plus 1, 6. 6 divided by 2. So equivalent EMF is 2 volt. If we combine these three cells in parallel, the equivalent EMF of this combination by the formula that we derived last class is coming out to be 2 volt. Equivalent internal resistance, because all three are same, equivalent internal resistance become 1 upon 3. So now this circuit can be replaced as there is one capital R. इन तीनों को हटा के हम एक बैटरी लगा सकते हैं. So there is one battery of EMF 2 volt and internal resistance 1 upon 3 ohm between A and B. Right? Now what we do here is in the question it says that so in this question, this is a little tricky question. A or B is not connected to anywhere else. Since A and B are not connected, it is not a complete circuit. So current बाहर तो कुछ में नहीं आएगी. There will not be any current in the outside resistor. इसका मतलब क्या हुआ? What does that mean? जितना इधर 2 वोल्ट का पोटेंशियल है उतना ही पोटेंशियल इसके अक्रॉस भी ड्रॉप हो जाएगा. दैट विल बी द सेम पोटेंशियल इट ड्रॉप. So that means the net potential across it will be 0. Are you getting this point? In this circuit there is no current because आगे का path completed नहीं है. तो इसकी current जो भी है वो अंदर ही अंदर आ जाएगी जब हम equivalent बनाएंगे. So the current will be in such a way that potential drop has to be zero.
सॉरी एक बार थोड़ा रिपीट कर दो.
तो ये थ्री सेल्स थे तीनों पैरेलल में, हमने इनका इक्विवेलेंट ईएमएफ और इक्विवेलेंट इंटरनल रेजिस्टेंस के फॉर्मूले से we calculated the equivalent internal EMF, equivalent EMF and equivalent internal resistance. We replace this whole circuit, three batteries by one single battery and its internal resistance.
Yes, sir.
So there is no current coming out. So हम ऐसा समझ सकते हैं. I mean, another way of understanding the same thing is कि जो potential difference यहाँ पर है 2 volt का, the same potential of this EMF is gone. So net ए और बी के बीच में पोटेंशियल डिफरेंस किसके इक्वल हो गया? 2 वोल्ट के इक्वल. जितना प्लस टू उतना ही माइनस टू होगा, सो दे बोथ विल कैंसल आउट ईच अदर. पोटेंशियल डिफरेंस.
Yes, thank you.
अब लेकिन इसमें हमें क्या बताना है? व्हाट आर द वैल्यूज ऑफ दीस थ्री करंट्स I1, I2 एंड I3? सो आइदर वी अप्लाई किरचॉफ लॉ, either we apply Kirchhoff law or we apply that concept. Potential difference का फॉर्मूला होता है V minus I into R and this is equal to VB minus VA. ये B और ये A. क्योंकि इस पूरे सर्किट में करंट तो है नहीं कहीं पे, सो केवल एक बैटरी आएगी. VB minus VA will be equal to minus of 2. Are you getting this point? इस सर्किट में से बाहर कोई करंट नहीं निकल रही है, इक्विवेलेंट ईएमएफ में कोई करंट नहीं है, सो द पोटेंशियल डिफरेंस VA minus VB is equal to 2. VA minus VB is equal to 2. This is the equivalent EMF that we got since current is 0. अब ये जो पोटेंशियल डिफरेंस है पहले सेल के क्रॉस, अगर हम इसको VB माइनस VA करते हैं, सॉरी ये उल्टा हो जाएगा. If you do it VB minus VA with our sign convention that we used, start from B, move towards A, बैटरी क्रॉस की माइनस टू प्लस, रेजिस्टेंस में करंट की डायरेक्शन में. This will be VB minus VA. So I1 R1 की वैल्यू है 1, E1 is how much? 3 volt is equal to VB minus V, that is minus 2. ये जो रेजिस्टर्स है इनमें कोई पोटेंशियल ड्रॉप नहीं होगा. क्यों? क्योंकि करंट ड्रॉ नहीं होगी. दिस इज ओपन सर्किट काइंड ऑफ थिंग नाउ. नो, सो हम ऐसे थ्री अलग अलग डिफरेंट सेल के लिए, सो फ्रॉम हियर I1 comes out 3 minus 2 by 1. I1 is 1 ampere. Likewise, when you do it for the second circuit, it will be minus E2 plus I2 R2 will be equal to VB minus VA. I2 is 2, so minus 2 plus I2 into 1 is equal to minus 2. So that means I2 is 0. In the second branch, there will not be any current. Similarly, third वाले के लिए use करोगे. So minus E3 plus I3 times R3 is equal to minus 2. And this was 1, so minus 1 plus I3 is equal to minus 2. I3 आ गया minus 1 ampere, so direction will be opposite. These are the current in these three branches. Read the question and then see the solution. What is the question? This is the circuit, network of the circuit. इसमें three parallel cells हैं, उनके internal resistances हैं. By using the combination of cell, we got the equivalent EMF, we got the equivalent resistance. Replace that. Since it is an open circuit, A and B is not connected anywhere else, so there won't be any current. That means the net potential drop between A and B is going to be just because of the equivalent EMF. करेक्ट? इवन समझ आ रहा है? गोइंग इवन
Yes, sir.
बेटा समझ आ रहा है?
हाँ sir.
You tried these questions before? No.
No sir, I have to attempt them.
You are solving questions from anywhere, if not the DPP, any other resource, SL Arora, NCRT, Akash,
Sir, I was doing SLL only.
and there is no doubt from SL Arora.
Not yet, sir.
Not yet means you have solved the exercise questions in between, that in text exercise questions for the Kirchhoff and this.
Sir, I was solving SLL for the previous chapter right now.
Yes, chapter.
Yes sir, UT आ रहा है.
अच्छा UTR. Okay, very good. UT आ रहा है और प्रीवियस चैप्टर पहले नहीं किया है, अभी फर्स्ट टाइम कर रहे हैं.
Sir, रिवाइज कर रहा हूँ.
नहीं, वो जो एक्सरसाइज आप कर रहे हैं डायपोल की, वो पहले की है या पहले नहीं की है?
सर थोड़े पहले नहीं करे थे तो वो कंप्लीट कर रहा हूँ.
Okay, very nice. Whew. जल्दी से क्लास ऑफलाइन स्टार्ट हो यार. आई ऑल्सो वांटेड टू स्टार्ट ऑफलाइन. तीसरी चौथी पांचवी वेव आती रहेगी. Okay. 6th we did, 7th we did, 8th I asked you to do in class, 9th, yeah. Question number 10. Question number 10 is again the similar method. You have to solve this right now on your own. 2 volt and yes, solve this circuit by using the same formula that we just did. These two 2 volt and 3 volt batteries are connected in parallel. हम ये कुछ क्वेश्चन क्लास में इसीलिए करते हैं ताकि आपको आइडिया मिल जाए एंड यू सॉल्व द रिमेनिंग क्वेश्चन ऑन योर ओन. अब आप थोड़े बड़े हो गए हैं और यू शुड बी. यस. So E1 by R1 plus E2 by R2 and R is also known. R internal resistance is 0.45. Potential drop बताना है हमें इस resistor R के across. We have to find the potential drop across this resistance of R. And R is 0.45. Right? Calculate the equivalent EMF. Equivalent EMF is E1 by R1 plus E2
5 by 2.
divided by 1 by R1 plus 1 by R2. Okay. 2
So 5
divided
to R1.
0.45 plus 3 divided by 4.5 divided by 2 divided by 4.5. So 5 by 2, that's 2.5. Okay, good. And our equivalent is 0.45 by 2 because they both are in parallel, so 0.225 ohm. Now we replace this. Four ohm and 2.5 volt, 0.225 ohm. Find the current. From current, calculate the potential difference. Yes, कितने आएगी current? Now I will be total EMF, which is 2.5 divided by 4.225. This is the current. Now potential difference will be I into R. हम ऊपर वाले रेजिस्टेंस से भी निकाल सकते हैं. This will be the same जितना potential across the cell. Terminal potential difference between A and B. This is suppose A and this is suppose B. So VA minus VB is equal to I into 4. 2.5 into 4 divided by 4.225. कितना आएगा सॉल्व करना? 10 divided by 4.225. 10 divided by 4.225. How much is that? 2.37. So I think it's the potential drop across resistor. ये पूरे की बात कर रहा है. VA minus VB. It's asking about VA minus VB, and this will be 10 divided by 4.225, and which is 2.37. Very good. Next. Yes, ये 17 question लिखते हैं. ये भी एग्जाम में आवा question. It's very easy. By the way, in the circuit shown, the current through 2 ohm resistor will be. कितना होना चाहिए इसमें 2 ohm में current? Kunal, what should be current in 2 ohm resistor? You don't need even pen to solve this.
सर जीरो.
Zero. जितनी 10 वोल्ट से करंट निकली थी वो 10 वोल्ट में वापस चली जाएगी. जो 20 से निकली वो 20 में वापस चली जाएगी. There will not be any current in 2 ohm. Right. ठीक है. Next is ये हो गया circuit cell and combination of cells. We didn't do questions from here. हमने लास्ट टॉपिक क्या किया था? रेटेड पावर. Yeah. Question number 3rd. Find a battery of 12 cells is required to send the largest possible current for the resistance of 10 ohm. Find the type of grouping which will give the largest current and estimate its value. Largest current कब मिलती थी? सीरीज में या पैरेलल में? In which case we get the in parallel. In series we get larger EMF, and in parallel we get larger current because internal resistance is reduced. Good, Shreya.
Thank you, sir.
Yeah, so there are 12 cells and each are required to send the maximum possible current. Current को increase करने के लिए we connect these cells in parallel. So there will be such 12 cells in parallel. each cell has a resistance of R is 6.3 ohm and EMF is 1.4 volt. That's given in the question. E is 1.4 volt and R is 6.3 ohm, ऐसे 12 है और हमें इसको यूज करके करंट सेंड करनी है टू वन एक्सटर्नल रेजिस्टेंस ऑफ 10 ओम. सेल्स को पैरेलल में कनेक्ट करने पे ईएमएफ इज सेम, सो ईएमएफ तो सेम रहेगा, इंटरनल रेजिस्टेंस हो जाएगा R by 12. इंटरनल रेजिस्टेंस कम हो जाता है, दैट्स व्हाई external is 10 ohm. Now find the type of grouping. It has to be connected, all should be connected in parallel, and the current that will pass through here. कितनी आएगी करंट? It is 1.4 divided by 10 plus 6.3 by 12. Okay. Continue. We will see one more theorem and both the wisdom of that. Did we do power transfer theorem also last class?
Yes, sir.
We power transfer theorem कर लिया था ना last class. What is the statement of power transfer theorem? What is the statement of power transfer theorem? What is power transfer theorem? Power transfer theorem, Vrishti. What is the power transfer theorem? When external resistance is equal to internal resistance, the circuit delivers maximum power. We derived this.
Yes, sir.
So ये जब भी हमने ऊपर लगा किया ना, हमें चेक करना पड़ेगा that this current is maximum or not, because power transfer theorem क्या बोलती है, किसी भी सेल में जब maximum current तब थी जब हम external resistance नहीं लगाते हैं, then all should be connected in parallel. Here the maximum power is when R is equal to capital R, or power maximum, then only there will be current maximum. The upala part hai, this is not necessarily true, so we need to check for the power transfer theorem also, that when the external resistance is equal to internal resistance, so वो इस सर्किट में अगर हम सारे को पैरेलल में लगा देते हैं, then circuit resistances are not matching. क्यों? क्योंकि external resistance है 10 ohm और internal हो गया 6.3 divided by 12, approximately 0.52 something. So these two are not equal, therefore circuit will not have the maximum power, not maximum power, so the current will not be maximum. For maximum current or maximum power, the external resistance should be equal to internal resistance. तो इसका मतलब ना तो सारे सीरीज में लगाएंगे, सारे सीरीज में लगाएंगे तो भी हो जाएगा 12 into 6.3, which is way beyond 10. So all cells cannot be connected in series, all cells cannot be connected in parallel. We have to use a mixed grouping of cell. We have to use an array of cell. So array वाले केस में हमने क्या किया था, n number of cells in series and such m number of branches in parallel. तो अभी हम एक general set ले लेते हैं that there are n number of cells in each branch and such m number of branches in parallel. We assume that this arrangement of 12 cells will give the maximum power or maximum current. m cells in series and m branches in parallel. Right? So n को हम अगर सीरीज में करते हैं, it becomes n times e. इसका जो इक्विवेलेंट आया था, that become ne. Each branch has internal resistance of nr, but as the m branches, so it becomes nr by n. Now this is the equivalent circuit that has to be used. External resistance is 10 ohm. Right? For maximum current, तो हमने ये बताया कि total number of cells here are 12. m maximum current या maximum power के लिए external resistance की value internal resistance के equal होनी चाहिए. That means n by m, r is 6.3, should be equal to 10. And the second equation that we have is total number of cells is 12, so m into n is 12. Total number of cells कितने हुए इसमें, m into n, that is 12. यहाँ से आ जाएगा m is equal to n by 10 times 6.3. Substitute here. ये आ जाएगा n square times 6.3 by 12. 120 by 63. 120 divided by 6.3. ये थोड़ा फ्रैक्शनल में आ रहा है, इसलिए we have to take the approximate value. I think m यहाँ पर सॉल्व करने पे ये n की वैल्यू आ रही है कुछ 4.3 and m is coming out 2 point something, so इसको हम approximately 3 ले लेंगे and n will be approximately 4 because number of cells cannot be, वो शायद डेटा की प्रॉब्लम है. On solving it should come out exactly integer, but अगर integer नहीं है तो हम उसके आसपास वाला nearest integer value ले सकते हैं. So that was the actual method by which we will find out. तो यहाँ पर क्या किया है शायद, okay. This is taken approximately 16 and m square will be taken as only 9. So 4 into 3 is 12, which is not exact value, but approximated to the nearest integer because m and n can be only integer. Power transfer theorem is external resistance should be equal to internal resistance, then only the total current, the current and the power in the circuit is maximum. Question number 5 शायद किया था अपने क्लास में. We did question number 5. Did we do question number 5 in class? Did we do question number 5 in class? थोड़ा question number 5 हमने किया है क्लास में.
सब शायद ये वाला नहीं करा.
नहीं किया.
कर लिया सर, कर लिया था.
कर लिया था हमने. Yes.
सर 0.5 है ना आंसर इसका.
5 या 0.5 आंसर. 5 भी किया
Yes.
था, 6 भी किया. Question number 10. 12 cells each having the same EMF are connected in series and are kept in the closed box. Some of the cells are wrongly connected. The battery of cell is in series with the ammeter.
सर कर लिया था ये.
ये भी कर लिया.
Yes sir.
Very nice. ठीक है, perfect then. So now we can go to the electrical energy and power. Yeah. This passage question is same as the one which we solved. Very nice. Next is electrical energy circuits, electrical energy calculation and electrical energy and yeah, electrical energy और electrical power दो अलग-अलग DPPC DC circuit power and energy consideration. DPP number 7 and DPP number 9. DPP 8 का कॉन्सेप्ट अभी हमें करना है क्लास में. Electric motor runs for 5 hours a day. At 220 volt, the supply wiring consists of copper wire 1 millimeter radius and length 10 meter. Power consumption per day is 10 commercial unit. Okay, leave it. Power consumption जरूरत नहीं है. Okay. Question number 6. क्या था हमने last class?
सर ये डीपीपी नहीं करी अभी.
ये DPP. Okay, ठीक है. So question number 5, electrical heater of resistance 6 ohm is run for 10 minutes for on the 120 volt line. So total energy liberated, energy का formula था V square by R into T, I square RT और V into I. तो यहाँ पे V पता है, R पता है, T पता है, so we can calculate. Question number 6. So we use the concept of rated power and rated voltage. Rated power, rated voltage से क्या मिलता है हमें? We get from rated power and rated voltage the resistance and maximum current that can pass. From the rated voltage and rated power. So we have rated power, rated voltage. By using this, we calculate the resistance. R is equal to VR square upon PR. और दूसरी वैल्यू हमें मिलती थी यहाँ से मैक्सिमम करंट और रेटेड करंट. IR is PR by VR. So अगर सपोज हमने किसी भी प्लान्स को जिसकी रेटेड पावर ये है, if it is connected, if the actual voltage supply is V volt, actual voltage supply is V volt, तो पावर कितना डेवलप होगा V स्क्वायर बाई R और R की वैल्यू है VR square by PR. So actual power developed in any resistor in any appliances having rated power PR, rated voltage VR. So in this question it says actual power produced or actual power developed in any resistor will be V square by VR square times R. V कितना है अभी? V हमने जो अप्लाई किया है that is 110 and rated was 220. So V is 110 and VR is 220. V is 110, VR is 220 and this has a 100 watt power. 100 by 4 that is 25 watt. 25 watt is the actual power जो कि हमें इस 100 watt के बल्ब से मिलेगा when the supply voltage is 110 volt instead of 220 volt. 220 is supposed to come, then the power would have been 100 watt. तो हम इस फॉर्मूले को भी एक तरह से यूज कर सकते हैं डायरेक्टली. Actual power is actual voltage divided by rated voltage square times rated power. ओके नेक्स्ट क्वेश्चन नंबर 7 सेम कितना वोल्टेज ड्रॉप हो रहा है परसेंटेज ड्रॉप हम कैलकुलेट कर लेंगे क्वेश्चन नंबर 8 सॉल्व क्वेश्चन नंबर 8 क्वेश्चन नंबर 8 में गिवन है दैट हीट प्रोड्यूस इन 5 ओम रेजिस्टर इज 10 जूल पर सेकेंड 5 ओम यानी ये नीचे वाले करंट में और नीचे वाले रेजिस्टर में ऊपर वाले में हमें कैलकुलेट करना है पावर क्योंकि जूल पर सेकेंड है पावर का फॉर्मूला हो गया आई स्क्वायर आर पावर इज आई स्क्वायर आर सो दी रेजिस्टेंस 5 ओम उसमें पावर के लिए हम पहले करंट डिवाइड कर लेते हैं इन द पैरेलल ब्रांचेस द करंट गेट्स डिवाइडेड इन द इनवर्स रेशियो तो जैसे ऊपर I1 नीचे I2 ऊपर का रेजिस्टेंस R1 जब हम करंट डिवीजन करते हैं इट इज इनवर्सली प्रोपोर्शनल टू रेजिस्टेंस I1 में आएगा R2 बाय R1 प्लस R2 टाइम्स I और R1 में I2 में आएगा R1 डिवाइडेड बाय R1 प्लस R2 टाइम्स I R2 is 5 divided by 5 plus 15 5 plus 10 15 into I so ऊपर वाले ब्रांच में करंट है I by 3 नीचे वाले में हो जाएगी फिर 2I by 3 the power delivered in 5 ohm resistance is power delivered in 5 ohm resistor is given as 10 joule so that means I2 square into 5 is 10 joule I2 is I by 3 square into 5 is 10 joule I स्क्वायर आ जाएगा 10 into 9 by 5 ऊपर वाले में हमें कैलकुलेट करना था द पावर डिलीवर्ड इन heat produced in 4 ohm resistor in 4 ohm resistor now the current that is going is I1 sorry I2 था 2I by 3 so ये 4 by 9 आएगा which means 5 into 4 जब 4 ohm resistance में कैलकुलेट करेंगे then that will be equal to I1 square into 4 I1 की वैल्यू आ गई I स्क्वायर I by 3 और I square by 3 I square we can substitute from this information 10 into 9 by 5 into 4 into 4 by 9 9 9 gone 4 4 gone that is 2 joule per second this will be 2 joule per second right so जब भी करंट डिवाइड होगी किसी रेजिस्टेंस में पावर निकालना है देन वी यूज for in resistance if you have to calculate power then we use I square times R right okay current in any resistance so ऐसे हमने question और next Question number 11. In a large building, there are 15 bulbs of 40 watt, 5 bulbs of 100 watt, 5 fans of 30 watt, and 1 heater of 1 kilowatt. The voltage of supply is 220. Find the minimum capacity of the main fuse. सारी power ऐड कर लेते हैं. The total power of all of these, and then divide by power P is equal to VI. From there we can calculate. From there we can calculate the total current, maximum current that can enter. Right? Very nice. Question number 12. मिल रहा है question number right. ठीक है. ये तो हो गया electrical energy. Next DPP number 9. So we have done both of these concepts, by the way. Now you have to solve the remaining questions. DPP number 9, which is on the power, electrical power and power consumed in the circuit. DC circuit, power and energy consideration. So first question we have done a battery of EMF E internal resistance R is connected to pure resistance. Determine the maximum power output. A condition for the power. This is the power transfer theory. Question number second शायद हमने किया है last class. Did we do question number 2? Shreya?
सर ये वाला याद नहीं.
एक बार फिर से कर लेते हैं. I think probably we did. When two identical batteries of internal resistance 1 ohm is connected, the resistances across in series across the resistance R, the rate of heat produced in R is J1 when the same batteries are connected in parallel. पहले केस में दो बैटरीज को हमने सीरीज में कनेक्ट किया. I think we did this question last class. पहले केस में EMF हो जाएगा 2E, इंटरनल रेजिस्टेंस हो जाएगा 2R which is 2 ohm. Heat produces J1. When the same battery is connected in the parallel, the rate is J2. So I1 and I2. We'll find out the current when the cells are in series and when the cells are in parallel. But I think we did, but just for once again, we can discuss this. when two resistors are connected in parallel, जब दोनों सेल को हम सीरीज में लगाएंगे तो ईएमएफ हो जाएगा 2E. First case is when there are two series resistors connected, EMF हो गया 2 times E. इसका internal resistance हो गया 2 ohm and resistance is R. Second case when they are connected in parallel, EMF E that becomes 0.5 ohm and R. We'll find the current I1 and I2. J1 is 2.25 times. It's given in the question that J1 is 2.25 times J2. It is I1 square R is equal to 2.25 times I2 square R. Current होता है EMF divided by total resistance R plus 2 square into R. That will be 2.25 E divided by R plus 0.5 times R. Solve this and find the value of R. It should be probably 0.5. I think we did this last class also. Easy question. Question number 2. Right? ठीक है, तो हमने ये पावर और एनर्जी वाले क्वेश्चंस कर लिए हैं एंड नाउ द रिमेनिंग क्वेश्चंस यू विल ट्राई एंड one thing that is left in this chapter is meter bridge, potentiometer and RC circuit, resistor and capacitor connected together. So on Monday we will be finishing with this chapter. ठीक है? Okay then. That's it for today. Thank you.